Hi everybody, my name is Brenna Myers. I am a junior studying exercise and sports science and neuroscience. Some things I like to do outside of school for fun are teach yoga, I run a book club, and I am on the UNC Club tennis team. So I want to be in Organic Chemistry 1 ULA because I have never been more motivated or shown a truer testament of what a growth mindset can do for a student. So, after the first exam, Dr. Beaver and I had a pretty lengthy conversation about what the growth mindset is, how I can implement into this practice some really important and valuable test taking strategies, and just overall how I can be more successful in this course. I was able to also talk to some ULAs, and they gave some really great advice and were very motivating, encouraging, and helpful. So, with all of this into account, I changed my study strategies, I changed the habits that I was doing, and I was able to demonstrate a over 20-point increase from exam 1 to exam 2. And although the grades are not all that matters, I have never felt more confident in the knowledge that I put down onto the paper in the exam. So, because of this, I want to be that person for the student coming in who's maybe not confident because they didn't do well in general chemistry, or they're just scared of the reputation that organic chemistry at UNC Chapel Hill holds. And I really feel that I could be this light for somebody and be the encouragement because I am a true example of how you can grow as a student in this class and not be afraid of the name that follows organic chemistry. Some things that I would like to implement as a ULA is definitely encouraging small group conversations in class. So, for the first 2 weeks of organic chemistry, I actually sat alone because all of my friends were in another section, and it wasn't until a ULA actually encouraged me to sit next to this girl and to kind of have a conversation and just be open-minded. And it actually sparked a great friendship. Me and this girl studied together outside of class, and we've had some really engaging and insightful conversations that have been super helpful in how I think about certain problems and how to approach different things, because everybody has their own takeaway, and sometimes what works for somebody else can actually be very helpful. So, for all of these reasons, I would love to be considered for this position. I think that I could really help people. I think it would also help me grow as a learner and as a student. So, I appreciate the consideration and thank you. So, if a student came to me with this question, the first thing I would tell them to do is draw in any implicit hydrogens or any implicit lone pairs that they think might be useful. I would recommend this just because if you really don't know where you're going, it can be helpful to see that you might have a pair of lone pairs that can act as a nucleophile. I would then tell them to label all of their functional groups and anything about the solution that we know. For the sake of time, I've already gone and done that. So then I would ask them, well, what reactions do you know that you can do with an ether? And hopefully they allude to something along the lines of an ether cleavage. I would then ask them, well, with an ether cleavage, what type of mechanism are we going to undergo? And hopefully they recognize that we're in a polar protic solution because of this hydrogen bond, and that is going to be indicative of a SN1 reaction. I would then recommend drawing out the actual mechanism. I would do this because when predicting the major products, there can be things that you miss in the mechanism that affect what your product is going to look like. And by drawing it out, hopefully you recognize things that you could miss before. So that's what I'm going to do, is start by drawing my arrows. So then we get something like this down here. And then we have to ask ourselves, well, with an ether cleavage, I know that it can be here or here. So I would ask the student, which do you think would yield the better structures? And hopefully they recognize that you cannot put a carbocation on this ring, as it would be very unstable, which means that we need to have a carbocation down here, resulting in our first structure of a phenol group, and our carbocation on a tertiary carbon. So then we need to stop because we have a carbocation and we know it can rearrange. Is there anything that can make this more stable with what we're given? And the answer is no. It's already pretty stable as a 3'. So then we're going to draw in our nucleophile. And if they don't know what the nucleophile is, I would just ask them to go back up to their solution and see what we have left that we can use. I would then tell them to draw their next arrow, attacking from the lone pair. And this yields this with our bromine. And I know in this problem that we do not use stereochemistry because we do not have an asymmetric center. But if we were using a problem that did, I would ask them with a carbocation, which ways can we attack? And hopefully that would help them think about what our stereochem needs to look like in our final products. And from here we can square or circle these major products that we're going to create.